Hey AP, in this video we're going to talk about LeChatelier's principle. So LeChatelier's principle is looking at systems at equilibrium and what happens when we apply a stress to them. In other words, we have the system at equilibrium and then we do something to it. How is it going to react? So according to LeChatelier's principle, any equilibrium system, when a stress is applied, there's going to be a shift in the position of the equilibrium to oppose that stress. Remember that for an equilibrium, we have this double arrow, which means I have a rate of going forward and a rate going backwards that are equal to each other. That has to do with the rates, not necessarily the amount of products. And I can look at to see, well, what side is being favored by given values and looking at their reaction quotient. I can also look at the equilibrium constants to see where does this equilibrium tend to lie. But what happens if I do something to it? Well, if I manipulate something with my reactants, I can either push my reaction to go further to the right, or if I take some of my reactants away, I'm going to leave a hole there, and that means my reaction is going to move to the left to fill in that hole. Similarly, for my products, if I add more products, that means I have more than what I need. It's going to shift away. It's going to use up some of these and go backwards. Or if I take away some of the products, it's going to make more to fill in that hole. And we talk about shifting, either right or shifting left. So if I shift to the right, that means that I'm starting in the middle and I'm really going to push my reaction to the right. So shifting right means that I'm making more of my products. I'm going to increase my products and I'm going to use up some of my reactants. So that's shifting to the right. If I'm starting in the middle, I'm at equilibrium, and I shift to the left, well, that means that I'm going to use up or decrease my concentration of products, and I'm going to increase or make more my reaction or my reactants here, their concentration. So I can shift back and forth. You could also have no shift, and that's where we look at something like maybe adding a catalyst. Well, that doesn't increase or decrease our amounts that we have of reactants or products or speed up or slow down our rates or anything. It just changes, one of the pathways that we have to make our reaction happen. So let's look at some different stressors that we can do to our system and then what they're going to do. So go ahead, pause this, and take a moment to copy these down. All right, so if I add a chemical, I'm going to increase its concentration. If I've increased the concentration of something, I'm going to shift away from it because I need to consume it and shift away. So if I increase concentration of my reactants, I'm going to shift to the right, I'm going to shift away from it. If I increase my concentration of my products, I'm going to shift to the left, again, away from it to consume the excess that I've added. Oppositely, if I remove a chemical, it's decreasing its concentration, I'm going to shift towards that because I've made this hole. So if I decrease my amount of reactants, I make this hole where my reactants were, and my products are going to break down and make some of my reactants to fill in this hole. So it shifts to the left. Or similarly, if I take away some of my reactants, I make a big hole here, it's going to shift to the right to fill in that hole. If I look at temperature, I need to look at, for both of these, I need to look at the heat of my reaction or the delta H of the reaction. Remember, if I have a positive delta H, it is endothermic. A negative delta H is exothermic. So remember, endothermic, heat is a reactant, and exothermic, heat is a product. So if I was looking at this reaction here, let's say it was exothermic, so plus heat. If I increase the temperature, it's going to move, my system's going to move similarly as if I increased a reactant or increased a product. I'm going to shift away. So if I increase my heat, my temperature, it's going to increase here, it would shift away from it. Just like with concentration, if I decrease the temperature, I'm going to move towards it. I'm going to make more heat energy. So if I decrease the temperature here, I would shift towards it. Now, pressure, I need to look at gas, right? Because pressure has to do with the amount of gas that we have. Because if I increase or decrease my gas, the moles of gas that I have, then I'm going to increase or decrease my pressure. So if I increase the pressure, that means there's, it's getting they're moving faster. Usually I've decreased the volume to make that happen. So I'm going to move to the side with less moles of gas if I increase the pressure. So I have to look to see, well, what are gas molecules in my reaction? And I have to look at the coefficients on front of those to see how many moles of gas molecules I have on the left and on the right. So opposite, if I decrease the pressure, well, then I can go to the side with more moles of gas because I have less things moving around. I can handle more moles of gas hanging out in my container. Volume works opposite of pressure, but that makes sense because they're inverse properties in terms of gas. So again, I need to look at the amount of gas molecules that I have. If I increase the volume, I have lots more space, so I can go to the side with more moles of gas. And if I decrease the volume, I'm going to have less space, so I'm going to go to the side with less moles of gas. And then if I add a catalyst, there's no shift in equilibrium because it just makes an alternate pathway. So let's go ahead and look at an example. So here I have the making of ammonia, and this should be a double arrow here to tell us that we have an equilibrium. And we can see that all of our molecules here are gas molecules. And we have a negative delta H, so we have an exothermic reaction, so heat is being given off. So let's say that I add hydrogen. So I'm increasing the amount of hydrogen that I have. Well, if I'm increasing the amount of hydrogen, that's increasing its concentration. I need to consume that, so I'm going to shift to the left. Okay. As I shift to the left, this is what's happening because of the shift. If I shift to the left, that means that my amount of products, actually, I am going to shift to the right. Like, see, you are wrong. If I increase this, I'm going to shift away from it. This is the right, as you all know. So I'm going to go to the right, which means I'm shifting away from what I added to consume it. So when I shift to the right, that is going to increase my number of products. So my products is going to go up its concentration. And therefore, because I've added too much of this and I need to make products to use this up, that means that my concentration of my reactants is going to decrease. Well, what if I remove nitrogen? So my nitrogen goes down. So now I have this big hole where my nitrogen is supposed to be. Well, my reaction is going to shift to the left to fill in that hole. So it shifts to the left, which means that my amount of products are going to get consumed. So they are going to decrease, which means that my amount of reactants, because I've taken this away, need to increase to reestablish equilibrium. Right? The rate of increasing them needs to speed up, and the rate of decreasing this is going to also speed up. What if I change the temperature? If I increase the temperature, well, temperature is a product. So if I increase the temperature, that means that there's extra energy getting taken out. So I'm going to shift to the left, so shift away, shift to the left, which again is going to decrease my products and increase my reactants. If I increase the pressure, increased pressure is less moles of gas. So I need to look at my moles of gas. Well, I have 1 mole here plus 3. So I have 4 moles of gas on the left. On the right, I have 2 moles of gas. So the side with less moles of gas is the right side. So I'm going to shift to the right, which means I'm going to increase the product concentration and I'm going to decrease my reactions concentration. And like I said, if we add a catalyst, there's no shift at all. So products doesn't change and reactants doesn't change.